Okay, good morning, students. Am I audible? Am I audible?
Yes, sir.
Yes, sir.
Okay, fine. So, in my last class, I think we had discussed on the aspects of the dams, is it not? So, today we shall continue our discussion on how dams are very important and how failures occurs due to the lack of geological knowledge in the dams. Okay, without the geological knowledge in the dams, how the failures can occur in the dam and how exactly it will lead to the cause of the failures, all we can see today. Yeah, so these are very important from the point of examination. No matter how many marks, definitely questions will arise from this topic. Okay, make sure that you make note of all the points. Okay. Okay. Yesterday we looked at the types of the dams and how the dams are being built. What are the types of dams and how they are built. So today we shall look at the most important aspect of the problems that are associated with dam sites. What happens is most of the dam failures are not due to faulty design or construction, but they are mainly due to the negligence of the geological factors. Okay, when you neglect the geological factors present in an area, then that will surely lead to the failure of the dam. Okay, because the negligence that is being caused by the dam failures is always attributed to the failure of the dam, because not 1 or 2 rupees, as yesterday itself I told you, lakhs and crores of together rupees have been invested into a dam. Crores of rupees, thousands of crores, okay, hundreds of crores will be invested on a dam site. If a dam failure means it is wastage of hundreds of crores rupees or even thousands of crores of rupees has been will be wasted. So that's why you have to have very comprehensive knowledge on the geology before you build a dam. Okay? So what are the main problems? See, the main problems are if you build what happens dams on shales, dams on soluble rocks, dams on strata dipping upstream, dams built on strata dipping downstream, dams built across the strike of the rock bed, and also dams on jointed and permeable rocks, and dams on fault. So these are the main problems that are associated with the dam sites. Let's look at all of them one by one. So what happens if you build a dam on a shale? Shale, as you know, is a sedimentary rock. Shale, as you know, it is a sedimentary rock. The rock is the composed of shale. Shale is usually made up of clay materials. Okay, shale is usually made up of clay materials. Okay, as you know, clay, what happens are stronger and do not disintegrate when subjected to wetting and drying. Okay, cemented shales, like means shales when they are cemented together with a very good binding material. When shales are cemented together with a very good binding material, then they are very stronger and they do not disintegrate very easily, even after wetting and drying. If the shales are compacted, okay, there is difference between cementation shales, and the compaction shales. Cementation shales are the ones which are cemented together, which are jointed together with some silica. Cementation shales are the ones which are cementation shales are the ones which are usually cemented together and they all possess a cementation material along with them in the form of silica, in the form of calcium, in the form of magnesium. Usually all these will be the binding materials which binds the shales together. But what happens in the case of compaction shales? See, compaction shales are the ones which are only compacted together. Okay, which means to say the particles are loosely held together. They are not very rigidly compacted, but they are very loosely held together by some action of friction within them. Okay, when those compaction shales are subjected, then those are very loose and they are very soft, and they are, when subjected to wetting and drying process alternately, they lose their strength. Okay, cementation shales are very strong because they are held together by cementing particles. Okay, the particles are binded together, and the binded particles always holds the shales on a very strong way. But compaction shales, on the other hand, are the ones which are not cemented together, but they're just bound by each other. Okay, now for example, when you start building a house, if you just lay the bricks one above the other or one side by side without applying the cement, what happens? They are simply put together, but they are not strongly held together. But if you apply cement, then it will be holded together very strongly. They will be binded very strongly. The two bricks will never be released, or it can not be removed, because they are held together very strongly. That is the difference between cementation shells and the compaction shells. So compaction shells, when they are subjected to wetting drying alternately, they become plastic. Okay, they become plastic when wetted and have a tendency to flow away from the area. Okay, swelling and cavity may result. Okay, so if a dam is constructed on a compacted shale, concrete must be placed immediately without delay to avoid the swelling and cavity action. Okay, so when it becomes plastic, so what happens is they tend to run away from that place. It has got the capacity to run away from that place, which in turn results which in turn results in removal of the foundation from that area itself. When the foundation from that area itself is being removed, then it leads to the direct failure of the dams, because the foundation itself will be broken down. Once the foundation will be broken down, then that results to the failure of the dam. What happens to dams on soluble rocks? As soluble rocks name itself implies, these are the rocks which can be soluble in water. So water acts as acid which can dissolve n number of reagents that come in contact with them. It can dissolve many of the minerals when it comes in contact with them. Okay, so dolomite, limestone, marble, which are all has got the capacity to dissolve in water. Okay, so these are the minerals which are made up of calcium carbonate. So these calcium carbonate has got the tendency to dissolve in water. So they dissolve in water and form solution channels and forms cave-like formations which are called caverines. Okay, so when they form cave-like formations or the caverines, the leakage of the water through them will be on a large scale, and a dam may not hold the water for a very long time. Okay, because all the water will be percolated into the layer of the earth through these caverines. When caverines being formed, then that results in the dissolution of calcium, magnesium, carbonates, all of them, and the minerals are being leached out or dissolved. When the minerals are being dissolved, then what happens is the water cannot be withstood in the reservoir for a very long time. Okay, the water should be holded or it should be stored in the reservoir. The main purpose of the dam is to store the water. When caverines are being formed, then that results to the removal of the water. Okay, so removal of water, what happens is that will not store the water for a very long time, and hence the water will not be present in the dams. So that's why you have to pay attention when you are going to build a dam across the soluble rocks also. Coming to the data, Dams and strata dipping upstreams. What happens when you build the dams and strata that is dipping upstreams? So what happens here is you can see there are two types of forces that are being acting on the dam. So these are the thrust forces, these are the natural forces, the forces which acts on the dams. It acts in three directions. One is directly on the basement of the dam, okay. Another one across the wall of the dam along which the water flows. Another one will be reversing in which it will act on both ways. This is one force, this is one force, and this is one force. This force acts on both ways, whereas this force, thrust force, acts on the wall, and neural force acts on the basement. So now, when you build a dam on strata dipping upstreams, so these are the strata rock types that are dipping upstreams. So when one of the layer of the rock is being removed, for example, if this layer of the rock is being removed, then what happens? Then there is collapse of this layer. Similarly, when this layer of the rock is being removed by any chances, then the entire collapse of the dam will take place. The collapse of the dam will be in this way. In this way, it will be removed because the forces will be acting on all the planes. If the supports of the dam is not being in a very clear manner, then there are chances that this rock may be removed due to some action, and that will result to the failure of the dams. Okay? Capable of supporting the weight of the dam or pressure of the reservoir. But what happens is resulting force acting on the right angles, the bedding plane. So what happens is the upstream tip of the rocks do not allow the water to percolate downwards from the reservoir. But there are chances this will be stable. This type of the dams will be stable. But what happens when these thrust forces, when the thrust forces act on the dam, what happens is there are chances that the water will percolate through these layers, through the bottommost layers, and reach this rock type, and leaching of the solution may take place, and the disintegration of this rock type may take place. So these are also the chances that the dams will have to face if the strata is dipping upstreams. Yeah. Coming to the data built on strata dipping downstream, these are very dangerous. These are very dangerous because, as you know, upstream ones will be capable of holding some material. Upstream data dams will be, or the upstream strata dipping ones will be, sometimes will be capable enough to hold the pressure that is being exerted on the dam. But these downstream ones are very dangerous because entire downstream, entire pressure on the rock of the dam will be present on the rock, and if one strata dips downwards or it is being removed, then the collapse of the entire dam will take place. Whereas in the case of upstream, what happens is even though one layer is being removed, then the other layers will act as a support to the dam. No matter the small amount of the damage may occur, the entire dam will not collapse, but there will be small amount of damage that will be occurred to the dam. But in downstream, what happens is if one column or one layer of the rock is being removed, then the entire weight of the dam, which is being laid on the foundation, will be removed, and henceforth, what happens is the entire collapse of the dam will take place. Okay, so that's why it decreases the stability of the dams. So what happens if the dams are built across the strike of the rocks? So what happens is when you build the dams across the strike of the rock. So this is a dam plane, this is a strike, not along the strike, across the strike. So if it is best when the area is made up of single rock type. So these type of the dams are very best if it is made up of a uniform rock. Okay. If it is heterogeneous in nature, then there is a possibility of leakage of water not only through the pores but also through the bedding planes. See, so this is the strike of the rock. So these are the rock types. this becomes the strike of the rock. So dam is built. So this is the strike of the rock. Dam is built across the layer. Okay. So what happens is, if it is of uniform layer, if it is made up of only one rock type, then what happens is the rock will withstand the water. Okay. So if it is multiple layers, what happens is it starts percolating to one layer, then automatically all the layers will start percolating, because different rock types have got different capacities to withstand the pressure. Okay, if it is uniform rock type, then it will have uniform material and it can withstand pressure in a uniform way. But if it is non-uniform rock, then the withstanding of the pressure will be very difficult. Henceforth, what happens is the dams which are built across the strike of the rock country rocks is also very dangerous. Highly jointed and permeable beds, it is very difficult, because so when you build them in a highly fissured areas or a jointed areas or a permeable rocks, even if it exists below the dam, it will not only causes the leakage of the water but also build up the uplift pressure at the base of the dam. See, when it is the leakages is very high. When the leakages are very high, then what happens is the jointing, the fissures, the veins, and the permeability, that is the movement of the water through the layers of the soil or the rock, increases. When the permeability or the jointing or the fissures are being increased in the rocks, what happens is the pressure at the bottom of the dam, that is the basement of the dam or the pressure at the basement of the dam increases. Okay, so when the pressure on the basement or the foundation of the dam increases, naturally there is a tendency to start the vibrations, because the thrust forces, the downward thrust that is being exerted by the water column to the foundation will be very high compared to the thrust forces that is acting normal to the wall. Okay, because the weight of the water is very high when compared to the side forces. So that's why this pressure at the basement of the dam or the foundation will start weakening the foundation, and henceforth, because of the weakening of the foundation, the entire structure may not bear the load of the water, and it may cause sliding and the structure may collapse. So that's why jointed and the permeable bits are also should be avoided. Coming across to dams and faults, so fault zones, as you know, these are the weaker planes that are present in the earth. The weaker planes that are present in the earth are called as the called as the faults. So what happens is these faults are very dangerous, because, as you know, these faults are very dangerous because there may be some of the movement like the hanging wall and the footwalls. It may be a reverse fault, it may be a normal fault, anything like that. If it is a faulty area, means there is some problem with the land. If it is there is displacement, that is if there is some displacement of the rock type that takes place during the earthquakes, then the entire structure may collapse, because one layer may go up and another layer may go down. It may be normal fault. The hanging wall goes down with respect to the footwall, it becomes normal fault. Or if the hanging wall moves up with respect to the footwall, it becomes a reverse fault. In both the cases, there is displacement of the rock type, which in turn results in the structural failure of the dam. That's why the fault zones are also discarded for the construction of the dams. Okay, so these are the very important problems that are being associated with the dam types. Coming to the reservoirs, next are the reservoirs are the ones which are the artificial lakes that are created by constructing the dams across the rivers. Okay, so these are the artificial lakes that are created by constructing the dams across the rivers, which are called as reservoirs. Okay, what is the cause of failure for the reservoir? So it may fail due to excess leakage of water or result of rapid sedimentation. These are the two important problems that are associated with the failure of the reservoir. because excess of water is being percolated through the layers of the earth, or it may be result of a rapid sedimentation. That is, the sediments may come and it may reach the reservoir, which in turn the water holding capacity may be decreased. So these are the two cases where the reservoirs may fail. Okay. So what are the problems that are associated with the reservoirs? So the main problems that are associated with the reservoirs are the groundwater conditions. See, groundwater conditions, permeable rocks, and the silting. These are the three problems very important. So what happens with the groundwater conditions? See, there are two types of the waters that are being present. One is effluent river, and another one is affluent river. So affluent river, what happens in affluent river is that in affluent river, even though the water table is on a higher scale, the water will be flowing in into the water table. Will be flowing into the water table, which always maintains the water table to a normal level. That is affluent rivers. In the case of effluent rivers, even though the water table is around the above scale, the water will be moving away from the water table. Okay, so in parts of Dakshina Kannada and Uttar Kannada, you might have seen that during the monsoon seasons, the water will rise to the top of the well. You can mug the water from the well without the aid of your pulley. But in case of the dry seasons, the water decreases down to the well. Is it not? You might have seen this condition. Why? Because this is the phenomena. That is the two cases. One is affluent river and another one is effluent river. If it is affluent river, even though the water table is present, the water will be moving in into the water table, which causes the water level to be maintained in the area. The water table will be maintained in the area. In the case of effluent river, what happens is the water moves away from the water table. So that's why the water table is not level of the water table is not being maintained. Okay, so that's why it may cause the failure of the reservoir. Next is the amount of water, that is leakage of water by the reservoir is called by the depth of the water table. So I told you how it occurs. Okay, by the case of the affluent and the effluent river systems. Permeable rocks. Now, what are the permeable rocks? As I already stated, the permeable rocks are the ones which are highly jointed rocks, or fractured rocks, or the faulted rocks, and the channels which cause serious leakage of the water from the reservoirs and also causes the landslides. Okay, so what happens is if a reservoir rock or this reservoir is located in such a permeable rocks area, that is where it is highly jointed, fractured, faulted, and even the solution channels is being present. What happens? If the rocks are being highly jointed, there are a lot of openings that is available for the water to percolate through the layers. Or if it is highly fractured, then water can percolate through those layers. If it is faulted, then also water can easily percolate through the layers. If it is in the form of solution channels, that is your limestone and dolomite and marble is being present, then water can form droplets through the cave-like formations. Caverns can be formed. So what happens is the water cannot be withheld within the structure. In turn, the water will be leaked out from the reservoir, and also it may cause some landslides. So that's why if a reservoir is present in a permeable rock strata, then it also causes some serious damages to the water storing capacity. Coming to the silting, so this is a very important aspect in today's day. The silting, hulu. In Kannada we call it as hulu. Every time the river flows, it carries along with it some mud, the clay particles, the stones, and other particles along with them. The moving water has got the capacity to take away with them some amount of mud, or even the clay, or even the soil particles along with them, and some sand particles along with them. The sand particles may be fine grained or it may be coarse grained, and also some amount of leaf and other particles are also being run away or washed away with the running water. Okay, so every year there is huge amount of sediment that has been carried into the rivers, into the reservoirs, which is being finally deposited into the reservoirs. So over a period of time, what happens is over a period of time, when these reservoirs or the silt particles starts to accumulate within the reservoirs over a period of time. Over a period of 10 years or 15 years or 20 years, what happens is more and more amount of the silt particles or the clay particles or the sediments are being carried away by the running water, are building up on the reservoirs. Why it causes some serious damage? Because it starts to accumulate as a thick pile of sediments, whereby the water storing capacity of the reservoir goes down. If it is comprising of more amount of the silt particles and sediment particles, then the water cannot be held to a maximum level. For example, if you cover a pot with half amount of soil and then you drop some water, or if you cover the water with some amount of the pebbles and then you pour the water will be can be stored only up to the mark. Below the pebble layer, you cannot store the water. Similarly, if the silting amount action of the water or the reservoirs or the rivers is more, then if the silt is present in a very huge quantity, then the storing capacity of the water goes down in the reservoir. Henceforth, what happens is the storage of the main purpose of the reservoir, building reservoirs, is the storing of the water, that goes down. So henceforth, silt silting is also responsible for the silting also is responsible for the decrease in the storage capacity of the water. Okay, so what happens is on such rivers where this is very common phenomenon in the northern Indian rivers, like the alluvial rivers of the Ganges and the Brahmaputra. Every year, what they do is a lot amount of sediments is being transferred along with the moving water. Every time the water moves, there is lot amount of sediments. Even in Ganges, Yamuna, the Brahmaputra rivers, which are perennial, are alluvial in nature, they have got the tendency to move along with them huge amount of sediments. Okay, so what they do is they build the silt traps, which will be constructed in upstreams in very close to the Kedarnath, and also very close to the Rishikesh, and also very close to Haridwar. They have built all these silt traps. Okay, so these silt traps, they check the rate of silting into the reservoir. Okay, and also they have made provisions to wash out the silt and passage through the passage into the dam, so that the silt will never enter into the dams. Okay, so this is about the dams and the reservoirs. If you have got any questions, you can ask me now, or else I'm going to stop my discussion today here. We should continue discussion next class. If you have got any questions, you can raise your hand and you can ask the questions. If you have got questions, you can ask me now, or else I'm dropping your attendance now. If you have got no questions, if you can raise your hand and you can ask the questions, or else we can continue discussion next class. Thank you.